Now I'm testing the HDMI out using by booting the Raspberry Pi OS, and here you can see the SD card and the CM4, and this PCB version is 5.4, and the HDMI is connected here, and this is the display PCB. It's showing the Pi boot menu, and here is the other display. And now I will move to solder other parts of the PCB and test them out. Today's sponsor is PCBway. They have PCB printing services starting from $5. You can order 10 PCBs in 9 different colors here. They also have 3D printing service, which is very reasonable. Go to the third section of the website and click 3D printing service and add your own STL file. Choose materials and other features and get a price. Check out their 3D printing service and PCB printing service from the video description below. So here is the 4-layer PCB without any components soldered. So I had to move to 4-layer PCB because of the HDMI signal integrity issues. Now we have 4-layer. So we have ground layer below this layer and ground layer below this layer, so that increases the signal integrity, and that solved the HDMI issue, I think. And we are using a new battery charging IC. Before I had used this different IC. This IC was from Top Power, TP5100, but this one is from Monolithic, and I soldered this and shared with you guys. This was working fine, and we are using the same USB PD IC, and other parts are same here. And you can see I removed the RTC and the IMU from this newest PCB because the layout didn't work out how I made it here. So I want to implement this to IMU and the RTC in the expansion PCB instead of the main PCB. That will make the debugging much more easier. Other than that, it uses the same layout for the 5 volt and 3.3 volt converter, and I fixed the problem with this USB. This is a USB in port, so I had to fix the CC lines. Now it's programmed as a power out, so you can take you can charge anything from this USB port. And next, nothing is changed in this part, and as well as this side. Then we can see the other part, and these parts, the ESP32 and everything is same here, and only thing changed for this parts on this side is the USB edit. This used to be in the display PCB, but this was using more lanes from the display connector, so I moved it to the main PCB. That way you don't have to program anything in the display PCB itself. Everything is programmed, or everything you need to program or debug is in the main PCB. The display PCB is just a HDMI out PCB. And now I'm to talk about different ICs or the bill of materials that will be in the version 5. The problem with making new hardware is it's changing every version. This is also not a final version. As you can see, I already ordered 4 PCBs, but with this one, this part of the switching power is not working, so I had to cut it off, and here then I had to solder manually. So this need to be fixed in the next PCB, that will be 5.5. And also I need to fix this edit programming. This 3 point will be integrated to the FPC that I talked about in the previous video. So I need to add more pins to have this programmable from this debug port or debug FPC connector, and that's one change. And if that works out, then I think we can have a final PCB that is, or that will be available to the public. Then you can test out or make your own PCB and test out. But the whole device, I think we need more time for testing, and I also need to put this PCB in the enclosure itself, then test out the mechanical part of it, the position of these connectors and these LEDs. And after that, I think I will release all the files, the 3D files and the PCB files, and hopefully then you can have all the files you need to make the version 5. And after that, I can move on, make some expansion PCBs that will use the PCIe connector, the GPIO, the Ethernet. Yes. Hopefully in the next version of 5.5, I have everything working, or that will be the final version of the PCB. Thanks for watching.